All right, so I'm recording now. So I'm Drew from NWA 3D, obviously. So you, Kyle? Uh-oh, you there? I can't hear you. You guys there? I lost audio. Can you hear me? Okay. Do you see like the little audio test? If you click on that little chevron that's down there next to the mic, you can choose your audio and make sure and select the microphone that you want to use. And you can even say audio settings and test it too. There we go. All right, we're back. Awesome. Something I meant wires crossed somewhere. Who knows? So,
Yeah.
it's you, Kyle?
Yes, I am.
And your name is?
Steve?
Steve. Hey. So, are you all teachers or techs or?
I'm the computer tech, and Steve is a teacher.
Awesome. What do you teach, Steve?
Computer technology.
Awesome. Yeah, this is perfect then. So, have you had any experience with your students with like CAD design or anything like that?
Not a little bit. In last year, we had a 3D printer that kind of shot craps, and so they've done a little bit with CAD design, but not very much. I was kind of waiting until to see whether this grant got approved on whether we would do more.
Awesome.
We've used Tinkercad in the past.
Yeah, Tinkercad is an awesome place to start. What kind of 3D printer do you have?
We had a Polar 3D.
Oh, oh no.
And yeah, it's been pretty much a disaster because we've sent it back and tried to get it back, and so
they stopped making them.
Somewhere in the world, not here.
Do you know that?
Yeah.
Yeah. So
they're not making them.
They stopped making them, yeah. So they just like completely stopped the line. So now you can like trade your Polar 3D in for like another printer that they are now reselling from another company.
Okay.
I don't know. So yeah.
Yeah, I tried to email them and I haven't heard anything back from them.
So that might be why, unfortunately. I know that you have to use their cloud slicer, I think, with it, don't you?
Yes.
Yeah. So that when I've tried to use them before, it was blocked on the school network I was trying to use it on, and then I've heard that from other teachers too, is like having a lot of trouble plugging the printer into the network and then trying to get it to be able to talk to it with the cloud slicer can be kind of a hassle, because there is a way that you can use like another third like party slicer where you can like plug right into it, but I don't know all the details of that on how to use it. But do you guys have it now, or did you ship it off?
Well, we
shipped it off, and then they never returned it. Or there were some problems returning, and they kept it, and now they won't talk to us. So
that's I'm sorry I'm laughing, but that's really weird.
It's a laughable situation at this point.
Yeah, it's like, well, this is ours now, so thanks for sending it to us. Like, what? Well, hey, now y'all got some of these, so we can rock and roll with them. So these are different than the Polar 3D because they use Cartesian coordinates instead of polar coordinates. So they use X, Y, and Z to move around. And the Polar 3D uses like a radius of a circle to kind of like be able to print stuff. So that'll be a little bit different, but otherwise like loading filament and stuff is kind of similar. So you might see some of those similarities. So yeah, Tinkercad's a great place to start. And then what grades do you teach?
6th, 7th, and 8th.
Okay, awesome. So once they get really into Tinkercad, another program that's awesome for like junior high and high school is Fusion 360. And that's like a more advanced modeler, and it's free for education, and it's our favorite one. So if you have some kids that are real precocious about like Tinkercad and want to take that next step, Fusion 360 is awesome because instead of moving primitives around like shapes, you can start with sketches and you can draw and then pull things up to be 3D and then like connect things together. And you can do parametric stuff too. So you can go back in the timeline of your design and change something and it'll change all the other features of your model. It's awesome. And I'll send you a link.
Now, is that a web-based software or program, or is that something you have to download?
Unfortunately, it's not. So like Tinkercad works on any computer, but Fusion 360 has to be on a Windows or a Mac. But do your students have Chromebooks?
Okay.
Yes, we have Chromebooks.
So you can check out Onshape. That's for Chromebooks, and it has a lot of the same features of Fusion 360, but it's web-based. So if you're interested in that, they have like levels of that too that are for education. So it's all free as well. And I'll send you a link that's got like our favorite modeling programs, and both of those are on there. And then SketchUp Education, they have one for Chromebooks too that kind of works for 3D printing. SketchUp's kind of hard to use with 3D printing because it's more for like architecture, but some teachers like it. So
that's called SketchUp?
SketchUp, yeah. And I'll send you links to all those. Like when I send you this video, I'll send you those. Because that's that first big step of 3D printing is that design step where you create a model.
Right.
And there's a lot of stuff out there already too. Like Thingiverse is a great website to get all kinds of resources and things like that from. And we've got a bunch of lesson plans on our website too. And Thingiverse is on that link as well. So and I'll send you guys that link so you guys can see it all too. Because we've got lesson plans for a bunch of different subjects, from computer science all the way to like reading. So there's your students can actually go in and edit the G code of this too. So you can't do that with Polar 3D, but you can change the code to like restart failed prints or to change the colors and things like that. Students can actually open up the source files, but that for the G code for the printers, and they can edit it and change it. And we've got tutorials for that. So that's that first step for 3D printing is that design step, and the one that takes the longest to do, which is awesome that that you have a technology class so students can have time and set time apart to do that. Because as you probably know, it's time consuming for them to make stuff. So once you have that file, you have to put it in a slicing program, which is similar to that cloud-based one, only this one isn't in the cloud, and it has to be on a Windows or Mac, and it's called Cura. And that's what we're going to install today. So it's on the SD cards. If you guys want to get it and install it on a computer, then I can walk you guys through how to set it up. So you have to set it up, and it's profile specific. So if you log into a different account, you have to do this again. But you'll set it up for the size of your printer, and then you'll load our profile in that's also on your SD card, and then it'll be all ready to print. And then you load models into it the same that you did for the Polar Cloud, and then you can adjust the size and scale and things like that. And then you'll just save those models as G-code files to the SD card as well. So that's how you transfer everything back and forth. So instead of having to worry about a cloud-based system, everything's on SD cards. So you don't have to worry about wireless connectivity or connecting networks or anything like that. So you can connect it directly if you'd like, but then if the computer goes to sleep or gets shut down or something, it'll fail the print. So we like doing everything separate, because then the printers can be autonomous even in another classroom, and they can be printing stuff out.
Okay. Yeah, because ours will be plugged in the back of a room.
Okay. Yeah, so that's perfect then. So you can design in one place and then print in the other. So that'd be great for that. And then the last step is just printing your models out. So everything on the printers is controlled with the screen. So the Polar 3D doesn't have a screen. It has like that cloud system. So this one, you can actually choose your prints, and you can level it and all those different types of features using the onboard controls. And those kind of how those 4 steps go through. So you'll make a model, you'll slice that model in Cura, you'll transfer the model to the printer, and then print it out using the screen controls. And then a lot of the troubleshooting with the printer comes in making sure that it's sliced correctly with your correct settings for the printer. And then the second one is making sure that your printer itself is calibrated properly. And that's kind of what we're talking about today.
Okay.
All right.
So I already have Cura installed.
Awesome. Which version do you have installed?
The 3.4.1.
That's perfect. Yeah, sweet. So I can share my screen with you, and we can go ahead and go over how to make sure it's set up. Does that work?
Yep.
Okay, awesome. Here, let me get to the same spot as you. So it should pop up and say like add printer.
Yes.
Does it say that?
Yes.
Okay, great. Here we go. I'll share my screen. All right, so we have our screen right here, and we're in the process of getting our printer on this list right here, but we're not in. Hopefully, we'll be in the next update or two to be in there. But right now, we're going to do custom 3D printer, and then this is the NWA 3D A5. Is the name of it, but you can call it whatever you want. just as long as you remember it. And then we'll click Add Printer. And then we're going to choose the sizes of our printer. So the sizes of this whole area is taken up by build space. So it prints this big, or about 5 by 6 by 4 inches. So the whole plate is actually build space. So the width is 125 millimeters, which is about 5 inches. The depth is 150, and the height is 100.
Okay.
And then this does not have a heated bed, so we'll leave that not checked. And then we're going to change the G-code flavor from Marlin to RepRap, which is the type of software that it uses, firmware. And then we're going to click Extrude right here, or it says Extruder 1 probably on yours if you're not on a Mac. And then change the compatible material diameter to 1.75. And that's what it says on the side of all of your filament too. Y'all get it?
Yep.
Okay, awesome. So then we'll click Finish. And then we have our printer set up, and you'll see kind of the build area right here. But then we need to load our print profile. So to do that, we'll click from Recommended over here to Custom. And then we'll click on the little drop-down menu here, and we're going to go to where it says Manage Profiles. And then from there, we're going to go to Import, and then navigate to your SD card, and then select inside that Cura folder the printer profile, normal quality, for the A5.
Okay.
And then, yeah, it'll pop up and be like, woohoo, successfully imported. And then we'll say, okay, did that work?
Yep.
Okay, great. So then we'll click Close. And then now we're going to activate that by clicking on this little down chevron and then select your normal quality. So then you want to make sure when you're printing that you have your printer selected right here. You have your material selected where it says Material PLA. And then your profile is that normal quality profile that we have. And then your slicer's all set up for your login. So once you have it here, then we're ready to actually import a model. So we've got some models on the SD card too. If you guys want to pull one in, we can kind of test it and experiment with it. So we'll click on this little open right here, this open folder.
Got it.
And then you can navigate to the STL files on the SD card. So on the SD card, we can go to STL files, and then from there, here, I'll change the view so you can see a little bit better. You can click one of these. So we've got a bunch inside there, but you can click whichever one you want. I'm going to go ahead and click on the keychain, and then just click Open. The computer's taking a bit to think today. Getting the spinning beach ball of doom. Uh-oh. Well, there we go. Then open, and then it'll open up inside of Cura. So you'll see it, and it's going to be yellow inside of it if it's printable. So if it's outside of that build binding area, then it's not going to be able to slice. So it's going to have lines through it, and it's going to say unable to slice. So you can take this, and you can move it around. So over here on the side, you can move right here, and you can move these arrows and add as many student models as you want inside that build area, so you can load them up. So having multiple printers is awesome, too, because then you can print like more viably in your class. So you can split up your prints and put like 2 or 3 on each one of your all's printers, and then finish stuff in like a couple days instead of having to wait a couple weeks to get everything printed.
Mm-hmm.
You can also click Scale here, and you can change the scale or the size of your model by changing this right here or these. So I could change this down to like 50% if I wanted. And then you can also rotate it. And rotating is important too, because you want to make sure you have the correct print orientation for your model. So if it's like at a weird angle or off to the side, it might have to print with supports. But if you rotate it in a certain way, it might not need to make as many supports. So even though those are automatically generated, and I'll show you here in a second how to turn those off if you would like, you can flatten stuff out. So for instance, this keychain, if I right click and kind of move my mouse a little bit, you can see it standing up, which isn't the best orientation. We want to go ahead and flatten it. So I'm going to click on this loop right here, the green one, and then flatten it all the way down 90 degrees. And then now it'll lay flat on the build plate and it won't need supports. And then over here on the side, these are all of your print settings. So there's a lot in here, and you can even click on this gear and see even more. There's tons and tons of settings that are in here. And mine right now, all of them are selected, but you probably see the basic settings right here. So they're not all selected. But if you ever want to see one, you can scroll over what they do, and then you can click on it. And we've optimized these that are hidden for you. But if you want to change any of them and play with them and see what they do, like, it's your printer. So have fun with it. Because you can always click on the profile or download the profile again from our website if something ever gets messed up. So we can click close here. And the most common things that you'll want to change are going to be the quality of your print, like the print density of inside, and that's called infill. And then making sure that if you want supports or not, then that's checked. And I'll show you those two things right now. So quality is right here. So that's how close the layers are together. So if that's a higher number, the layers are going to be thicker. So it's not going to look as good, but it's going to print a whole lot faster. Medium quality is about 1.5 to 2 to 0.2. That's your range pretty much for medium quality layer height, which is we found that we print most of our stuff at. It's a good mix between like speed and quality. If you want to go for really high quality prints, you can do 0.08 or 0.1. And then if you want to do low quality prints that print really quick, you can do 0.3 as the lowest and fastest print that's going to print out. And it'll goop that filament out and make something. So if you want to change that, you can change those values, and that'll change the print time of your print, depending on what you like to print. So then if we scroll down a little bit, you'll see infill, and that's the model that's the stuff that's filled inside of your model itself. So it's kind of like a crosshatch pattern that goes through your printer. So it'll print the inside of your model denser if you want it to be smaller and stronger, but if you want it to print fast, you could have it hollow or even like 5% filled in, and it'll just be barely anything inside of there. And we usually leave it between 5 and 20% depending on what we're printing. And you can even change the pattern too. And you can see when you scroll over, it'll tell you what it does. Grid's the default, but if you want to change it to something like triangles or lines, you can change all those as well. And then a note on the print speed, 50 to 60 millimeters a second is as fast as you can reliably print. So these can print like 3 times faster than that. But if you crank them up to print really fast, they have a tendency to fail more often because it's just the chemical process of the layers binding together. If it's going super fast, they might not adhere together really well, and that could cause you to knock your model loose or your layers not to stick well and stuff like that. So we like to err on the side of successful prints. So we go to 50 to 60 is pretty much the maximum for any material extrusion 3D printer like this. And then the support, that's generated right here where it has this support. So it's automatically going to make it if it ever needs it. So if you have an overhang, like let's say you had a doorway in a house and it needed to make the support inside that doorway for it to be able to print, it'll just generate that support structure, and then you can just pop that out when the print's done. So that's why you have the pliers and tweezers and stuff like that in your toolkit, so you can clip all that out. But if you don't want to have support and you want to try to print it, it can print at pretty steep overhangs too, and sometimes be successful. So you can uncheck that box, and that can speed up your print time as well. So when you're ready to print, you can change the name of your model. So I could change this to keychain right here by clicking on this little pencil and then hitting enter. And then when you click prepare, that slices your model. So that's converting your model from an STL file that you made in Tinkercad, for instance, to the G-code that the printer reads. So it has to go through this step to get to the printer. And then once it slices it, it'll tell you about how long it's going to print and how much material it's going to use. And usually that's within like 10 minutes of time. It's pretty accurate, which we like a lot too. And then if you have your SD card actually plugged into your computer, you'll see a little thing, let me put mine in here, that says save to SD. And then when you click that, you can save it to a file. If you wanted to make a folder that says, you know, like 7th grade and a folder for 8th grade or something like that, you could, and like save them all in the same place. You could do, you know, like 8th grade blue, and that would be all your blue models, or 8th grade, you know, 7th grade green or something, and you can save them all together in different spots. Or you can just save it straight to the removable drive. So I can click save to removable drive right here and save it right on. And then once it's saved, you can just hit eject, and then that'll eject it out. And then that little micro SD card that's inside that dongle That's what you'll take out and put in your printer. And that's that third step where you're transferring it to the printer itself. And it just clicks in and clicks out underneath that little knob that's on there.
Okay.
So yeah, if you guys want to take your SD card and stick it on there, then we'll be good to go. So do you have any questions about Cura and how that works? Or want me to go over any of it?
Well, I guess you said you can pull multiple STL files on the
Yes.
through Cura.
Yeah, you just load another one. So you
like,
just click open file, and then you can just choose another one. Like I could click this sphere and then choose it and say open. And as long as both those files are yellow, then they'll both print. So you could load that build plate up. So you guys want to move on to printing something?
Yeah, we're
Sweet.
we hesitated taking everything out because we weren't sure if it
Yeah, no, let's totally do that. So yeah, let's take it out, and then let me change my camera here so you can see. We also want to put together the spool holder.
we did. We got one ready.
Okay, sweet. And then if you want to get some filament and take that out of the plastic that's around it, just make sure that you pull it through this little hole in the side when you're not printing, because just like weed eater line or fishing line, it'll get tangled up if it's not like pulled tight through here.
Yeah.
And then I'll build my spool holder real quick here, and then we'll be able to use that. And then y'all have it plugged in?
Yeah, we're plugged in.
Okay, awesome.
And where did you say the SD card goes?
It's going to go with the gold contacts down right underneath the knob right here. Right there. And it'll click in and click out.
Okay.
So with operating the printer, there are 4 big troubleshooting steps to keep in mind. The first one we just went over was making sure those Cura settings are all correct. So making sure those settings, like if they get messed up or set up for another printer, that can get real wonky real fast for your printer. So that's why you want to make sure they're all good to go. The second thing is making sure that your printer itself, all the machine stuff on it is actually functioning properly. So you're basically checking the machine integrity. The most common thing that happens in shipping is these cords come unplugged, or if you move them around a lot. So if you want to go ahead and check and make sure all the cords are plugged in, and then kind of just look over the printer and make sure nothing looks glaringly like broken or bent or cracked or anything weird like that. It should look like a pretty solid little machine. And if something's weird, then let me know.
Yeah,
So,
the one we have out looks good.
Okay, awesome. And this is covered with a 1-year, no questions asked warranty too. So everything is covered. If it falls off the table and breaks, it's covered under warranty. So we want to cover it no matter what happens in your class. We'll walk you and your students through how to fix it. And then if not, it's really modular. So you can take the parts apart and ship them to us. And then we can fix them and get them shipped back and make sure that they keep functioning in your classroom. So now that we've kind of checked and make sure everything's going good on it, what we're going to do now is we're going to go ahead and load our filament. So we'll plug it in. And then the filament is going to go in right here on this little part. So you can squeeze this right here and then feed the filament through. And on your SD card, we even have this little filament gear that you can print and upgrade for your printer if you want. And it'll sit right here on top. And then you can twist it to actually feed your filament in or out. So you can set it on there, and then you can spin this to actually move your filament in and out instead of having to squeeze this lever right here. So we'll kind of take our filament, and it helps sometimes too to kind of cut it at an angle. So you can use the clippers that come inside of your tool bag too and kind of cut off the melted stuff at kind of a point to feed it in there. And then it's going to feed through this hole and then through here and then all the way through this blue tube. So we'll kind of shake it a little bit and then feed it all the way through. And then having this knob on there, if you guys want to print that knob, you can just turn this knob and that will feed it all the way through too. Because it's got to go all the way through this blue tube, all the way through till it won't go anymore. All the way to the end. And then when it gets to the end, it'll stop and you'll know that it's in there.
So it's going up and through?
Mm-hmm.
Sweet. So mine too, so yours is lifted up in the air a little bit. So I'm going to lift mine up like yours. So you can just hold on to it right here and just it moves right up. And then when your filament, it goes all the way through about 8 inches until it won't go anymore. Then we're ready to heat the nozzle up. So to load or unload the filament, the nozzle has to be heated. And that's because it's going to be actually hardened inside of the end of that nozzle, kind of like a funnel. So to do that, we'll tap on this button and then tap setup. And then we're going to go to preheat PLA. And right underneath that, you'll see preheat soft pull. And that's what you'll use to remove the filament. But we're going to just do PLA. And soft pull, it heats up to 100 degrees, which is where it transitions from a solid to a liquid, and it's kind of like cleaning out your 3D printer. And that's why you can pull it out when it's at least 100 degrees. But PLA will heat all the way up to 220. And then when it gets heated up to around like 200 or so, then we can actually push on this gear right here and either push the filament in, or if you have the little wheel, you can twist this, and it'll actually push the filament through the end of the nozzle. And then you'll see the filament coming out the end of the nozzle, and you'll know that your 3D printer is primed. So issues with the filament, sometimes having it like jammed or clogged and stuff like that, the most common way to make sure that that doesn't happen is to make sure that it never stays on and heated when it's not printing. So just the best thing to do for that is just have it unplugged if you're not printing anything. So, and when we get all this filament load and stuff, that's why we're going to unplug it. Because this PLA is made from the sugar in corn. So just like leaving something in the oven too long, it can bake. And the filament that you have, if you still have filament from your Polar 3D, it's 1.752. So you can use that same filament on this one.
Yeah, I was going to ask you that. Because I've still got most of the filament from that.
Awesome. Yeah, so you can use all that. Just make sure it says PLA. I think it is PLA, but it varies. It can also print in PETG with a little bit of tweaking. So yeah, when it gets up to about 200, you can push it, and then you'll see the filament kind of coming out the end. Or like if you have the wheel, you could turn the wheel a little bit, and that'll feed the filament through.
Yeah. Oh yeah, we got it.
Awesome. And then when you see it coming out the end, you can go ahead and unplug the printer.
Just from the power?
Yeah, you can just unplug it.
Okay.
So then we turn that off, and it helps you like unplugging it from just to make sure that it doesn't just stay on. Now it can cool. Like if you print something over the weekend or something, overnight, and it's done at like 4 a.m. on a Sunday or something like that, that's fine because it will stop and then move to the side and then cool itself off when the print's done. So that's totally fine. It's just you don't want to leave it on when you fed filament in it for long periods of time because it will bake the filament into the end here. And we can help you go through some steps to take it out. And if ever you feel like you want to take this thing apart to get to the filament, it has to go together in a certain way. So anytime you feel like busting the tools out, you totally can, but please contact us first, and then we'll help you repair it.
All right.
So we can go ahead and plug it back in. And then if you want to use the pliers or something to grab that filament that came out of your nozzle, you can grab it and get it out of the way if you want. Or you can just leave it there. It's fine. It cools within about 5 minutes, or within about 5 seconds, excuse me. So the filament's cool right away. And the only part that gets hot is the nozzle itself. So this doesn't get hot, only the nozzle. So once we've got it plugged in, we're ready for the final step and the most complicated step of 3D printing, and that is calibrating the build plate to be even all the way around away from the nozzle. So if it's too far away, then filament will curl up on the edges or knock loose, or it won't stick at all. And if it's too close, then it might not print part of your model, or it might dig into the build plate or make like clicking sounds because it's trying to feed it through. So what we're doing is we're trying to find like a happy medium between there. And this is going to be done by adjusting each one of the bolts underneath here, so there are 3 of them, to level the plane. So to start off, what we're going to do is we're going to go ahead and tap the button, and then go to Setup, and then Auto Home. And then that is going to move the X, Y, and Z to 0. And then we're just going to get a folded piece of paper. So any sort of folded piece of paper will work. Printer paper works the best. And we're going to use this as our gauge. So if a single piece of paper is about 0.1 millimeters, so folding it is about 0.2 of a millimeter, and that's what we're looking for our leveling. So once we've got it homed, we're going to tap on the button, and then go back to setup, and then tap disable motors. So when it stops moving, we can disable those motors, and now we can actually move these around. So we can move the plate and our motors around. So we're going to move this to where it's like underneath the N in NWA 3D. And my plate's on backwards, and that's fine because I can just take this off and flip it around because this is removable. So you can take this off and flex it and pop your prints off of it, and that's why it's got these clips on there. But you have to print with it. And this kind of takes the place of painter's tape or any other surface because it's specially designed for filament to stick to it. So if this is clipped on, then kind of underneath the N in NWA 3D. Sweet.
Okay.
So then now we'll take our piece of paper that's folded, and we're going to fit that underneath our nozzle and our build plate. So if it doesn't go in there, then you can actually push down on the build plate and get it in between it.
Okay.
And then you can drag it to drag your piece of paper. And what we want is we want it to be dragging with quite a bit of tension on the nozzle. So imagine like if you set your finger on the paper and you feel it dragging on your fingernail, that's what you want it to feel like. So when you drag that piece of paper, how's it feel?
It's very tight.
Okay, so if it's really tight and like buckling.
I can pull it, but I can't push it.
Okay, so if it's buckling, it's a tiny bit too close. So what we're going to do is on this little knob down here, we're going to turn it about 1/4 of a turn toward the screen. So we'll turn it like this direction a little bit, just one little crank, and that tightens the spring, which pulls it away from the nozzle. So I'm going to turn it just a tiny bit that way, and then test it and see if it's dragging. There we go. Now mine's a little bit better too. And the trick is like a tiny increment and then test it, and then a tiny increment and then test it. And you want to be able to move it back and forth with like a thumb and forefinger without it buckling and still feeling it drag. So it's kind of a weird mix between like guesstimation and exact measurements.
Okay, we're good on that one.
Got it? Okay, sweet. So then we'll grab the plate then, and you can probably guess what we're doing now. We're going to do the one in the back corner. So you can pull this forward and then adjust this back nut right here to be the same. So I'm going to drag this one here, and this one's a little bit tight, so I'm going to do the same thing. I'm going to crank it a little bit toward the screen. And that will tighten the spring and make it looser on top. And you're looking to get it about the same consistency of dragging as you felt on the front corner.
Okay. All right.
Sweet. And then the last one is the one on the inside. So we'll move the plate to the middle and then move this all the way to the middle of the plate and then test that. And you should be able to drag it back and forth there too with like your hand on the paper like this. And mine, see, it's a little bit too loose, so I'm going to turn it the other direction. So I'm going to turn it a little bit away from the screen, and that will loosen the spring and push the build plate up a tiny bit. So I'm going to pull the plate out toward me and then adjust it a tiny bit and then move it back and then test it. There we go. Now it's closer. And then just like the outside ones, we want to get it about the same level of dragging as we feel on there. And this is definitely the most complicated part, but it's also probably 85 to 90% of 3D printing is making sure that it's level.
Now, once this is done, how often do we need to revisit this?
So that's a good question. It kind of varies. So if you move the printers around, and it can kind of move the springs up and down, and usually I kind of check that it's level every print, and just to make sure it looks good. And usually maybe every several prints, or maybe like I had one school that they went 6 months without leveling it. It just kind of varies. Most of the time the springs will hold the level pretty well, but it's good to just kind of check it and watch the first layer. And we're actually going to print a leveling G-code right now that you can print to test to see if it's level. So once you think you got it pretty close to level, we're going to print this G-code and then hot level it, which means we're going to adjust it by tiny increments while it's printing. And you can do that with the first layer of any print to make sure it looks nice and smooth.
Okay.
Y'all think you're ready?
We're ready.
Sweet. Okay, so before we print our actual model, you could print it right now and we could test it, but we're going to print the G-code just to make sure that our printer is level itself. So what we're going to do is we're going to click on the button again. And then we're going to move to where it says refresh SD card, because we took the SD card out while it was on. And then go up to print from SD, and then you'll see your G-code right there that you saved from your computer, but we're going to go to test prints, though. And there's a bunch of prints inside of there already. So we've got different models in there, like the spinning knob for the top and some other stuff in there that you guys can print. But I'm going to go down to where it says A5 leveler, and then tap that button. And then that's selecting the print. That's that fourth step. So what it's going to do is it's going to heat up to 220 degrees. It's going to zero itself out, and then it's going to start printing. Now this bill plate, it's made to get really dinged up because it replaces tapes. So it's always going to kind of ding up this front corner right here. And you can just clean it with some alcohol if you want to, and you can even scrape it flat if you get some divots and stuff, and it'll still print well on it. This is just a sticker that is like a consumable for the printer that sticks to this other plate that's right here that's removable. So you can replace that sticker if it gets really bad, but it'll probably last a year or two, if not more. So now what it's going to do, it's going to heat up to 220, and then it's going to start. So what do you think? Y'all got any questions?
I don't think so.
Not currently, no.
Awesome.
Now, in the future, if we do have a question, and you may get to this later, is it something where we just email you? Is that the easiest way to get questions answered?
It varies. So any way that you can get a hold of us works. So you can email me if you have any issues. You can also like call us, and I'll send you our phone number too after this. And then we also have a tech support form on our website. So if you email me with like a question to help out with like a lesson plan or something, then I can totally help out with that. But if it's service for the printer that you're looking for help with, then we'll direct you through our portal so we can capture the serial number and stuff like that. And that's right here on the side.
Okay.
That's the website. So it's nwa3d.com/service. That's to get to the website. And we even have student portals too. So we love to do tech support with students and teach students how to use it. So they even have a slot where they can they can send an email and put in your email, and we'll copy you in all the correspondence. And they can even click through and choose things almost like a choose your own adventure and be like, my printer isn't sticking. And then it'll direct them to stuff on how to help them level and things like that are on our user manual. And it'll kind of like direct them in those directions. Or you can just contact us and just submit that tech request and we'll get you going. So pretty much any way you can get a hold of us. We even have chat on our website. You can even type that in, and we can share all the links with you and help you out. So any way you feel like getting a hold of us. So what it's going to do is it's going to go to the middle and put a little square in the middle, and then it's going to go to the outside and do a rectangle on the outside. And it might take it a second to do the one in the middle because it's building up pressure inside of that nozzle. But then when it goes to the outside, that's when you want to check. And we're going to let it go all the way around once, and then we'll kind of see the state of that line because it's going to go round and round and round 7 times. So we want to make sure that the lines are nice and flat, and then they're stuck together and you don't see gaps between them. So what do you think? Does it look like there's filament sticking?
Yeah.
Awesome. So now that it's went all the way around once, what you can do is you can actually try to move your finger across the filament and see if it knocks loose. And you can use your fingernail too. And if it knocks it loose, it's a tiny bit too far away. And does any of it knock loose or does it stay stuck?
It seems pretty stuck on there.
Awesome. Yeah, and if you don't see part of the rectangle all the way around, then that means that it's too close. So you need to adjust it in the opposite direction. And then once it goes around twice, then we'll be able to do some real good fine tuning. So what we're looking for on the lines is for them to be flat and fused together. So if the lines are separate, then that means it's still a tiny bit too far away, and we'll need to move it up a little bit. But if the lines are flat and they look like they're stuck together, then that means that it's good. So for instance, this corner right here, I can see a little bit of a gap in it. So I'm going to crank it about 1/8 of a turn away from the screen, and then that will push it up a tiny bit. And then the one that's always going to look kind of weird is this back right corner, because that's what builds up pressure. So just so you know, that one's never going to look perfect. But I can see still here, it's a little bit farther away. So I'm going to crank it a tiny bit. Boop, just a little bit. But then the inside one, it's nice and flat, and these lines are fused together, so it's perfect. And then you kind of let it go around and see what it looks like, and then it's going to go round and around until you get your lines looking nice and flat like you want them to. So what do y'all think?
I mean, it looks good to me. I don't see any gaps in the lines. It seems to stick to the build plate.
That's awesome. Yeah, that's perfect. So you can also, you can scrape this off while it's printing. So you can get your spatula and kind of pop it off. And then when you pop it off, you can look at it. So I can see here, like this corner, it's all stuck together. So that's what we're looking for. And this corner stuck together, which is great. But then this corner, they're kind of separated a little bit. So this one needs to go a little bit closer. And this one's tough because it's in this back left corner. So it's actually adjusted by the inside one here, the one back here, and even a tiny bit by this one. So I'm going to first adjust this one in the inside to make it a tiny bit closer. So I'm going to wait for the plate to come forward, and then I'm going to move it a tiny bit, kind of have my hand over there, kind of move it a little, and then kind of adjust this back one too, and kind of crank it a tiny bit to get closer as well. And then you want all the lines to be stuck, so it's like one solid rectangle all the way around.
So if the pieces are, like our back left corner is not sticking, do we need to then move it closer or farther away from the?
Closer. So yeah, is that the back right corner or back left?
Back left.
Okay, so the back left is the most difficult one. So it's going to be the inside bolt right here, and then this top back right bolt too, and then a tiny bit on the front one. Because it's a plane, that's a triangle. So I'd crank it about 1/4 of a turn on this inside one, and then on this one back here, and then maybe just a tiny bit of a turn on this one. Just a tiny crank, and then see what it looks like. And a lot of it's just kind of trial and error and figuring out how the build plate itself levels. And it takes some practice for sure, which is why we're here to help. So even mine is still a tiny bit farther away. So I'm going to even adjust this one. I'm going to move my front one just a tiny bit. And then that will push it up like this and kind of level it out a little bit more. Let's see what that looks like. And it's going to keep printing on the outside of the lines too. So you can see, and you want those outside lines to look better than the inside ones. And even if it's stuck, it might still print. It's just it could warp up if it's too far away. And it would kind of, as it contracts, it could kind of warp up a little bit.
Yeah.
And I'm going to let it come forward. And then as it comes forward, I'm going to turn that little knob a tiny bit underneath there. Just a tiny bit with like one finger.
And you said to tighten it, it's turn it away from the screen?
To tighten it, yes. Because that will push the build plate up, which loosens the spring on the bottom. So if you're ever curious about which way you're turning it, you can look down at the springs when you adjust them, and you'll see the springs loosen and tighten, depending on which way you turn it. If it's too close, then you'll see like part of it that's not coming out. Or it might be like dug together as it's printing around too. So what do y'all think? Looking pretty good?
Yeah, still needs a little adjustment, I think, but it's looking better.
Awesome.
Now you said to adjust the front one, so the hard knob, turn that about 1/4 of a turn, and then also turn the back right one?
And the back right one a little bit. And then even this front one a tiny bit affects that back one because it's 3 points. So imagine it's a point here, and a point here. So when you adjust it, the whole plate moves around.
Okay.
And then you can see too, like since this one's done, I can pop this off and kind of look at it. And that back corner is the hardest one to get.
Yeah.
And sometimes if they're a little bit separate, see mine's still a little bit far away too, it'll still print. It might curl up on your print and stuff like that. So it's just like fine tuning and kind of getting used to what it's like to fine tune it.
Okay.
And as long as it's consistent all the way around, maybe even a little bit too far away or a little bit too close, you can still get consistent prints on it.
Yeah, I mean, I think ours look pretty good.
Okay, awesome. So yeah, you could just hit the button and then select your print, and you're good to go. So that's all I got, y'all.
Okay.
So do you have any questions? Does that make sense?
Yeah. I think that's just the process of going through and making sure it's level.
And that really is the most time-consuming thing. And it doesn't have any fancy bells and whistles or anything, which is what makes it so reliable, too. So once you get it tuned in and you figure out how to do it, you'll be able to level super fast. And usually, like, running that leveling G-code is the best way to kind of get it nice and fine-tuned. So if you print something and it's just not working right, then you can do that leveling G-code and you'll be good to go.
Will it say on here how long the approximate print time is?
Yeah, that's a great question. So it'll tell you how long it's been printing, and those are the minutes. And then that little progress bar that fills up, that will fill up all the way through to the end. So it's kind of telling you from both directions. So how long it's been printing, and then that progress bar is how long it still has to print of the model.
Okay. And then, so if we're printing something overnight, we can let it go ahead and print overnight, and it will shut itself off.
It won't shut itself off, but it'll cool itself down. So it'll get done and it'll move to the side and then cool itself down. And that's totally fine. Like, I print stuff overnight all the time. I've got one at my house I print on constantly. And we've got these in over 600 schools. So it's totally safe to leave printing.
Okay. I can't think of any other questions.
No.
From a teaching standpoint, you've got so it's under the education tab. Is your lesson plans and like that?
Yeah, we've got a bunch of lesson plans on there. And then if you want help coming up with like customized lessons, I'm a certified teacher, and we have another one on staff too that can help you come up with plans and stuff like that. So you can share like your standards or hey, I've got an idea and I want to work with cell structures or something. We'll totally work with you to build something that works for your curriculum for free.
Okay, awesome. I guess then the other question that I have is if we wanted to change colors through a build, you said we could get into the G-code.
So yes, that's on our website. Yeah. So you can go to computer science and then you'll find that tutorial on how to do that. You can also, while it's printing, you can tap the button and then say change filament, and then the filament will change. And having this little knob upgrade, it helps for that. Like if you are going to do the leveling G-code, we recommend having this little knob, and that's why it's a G-code that's on there for you too. So this knob helps a lot.
Yeah, that's what we're printing off right now.
Okay, awesome. Yeah, so it helps a lot to be able to load and unload the filament, because then you're not having to squeeze it. Because if you accidentally push down on the gantry when you're changing colors, it'll dig into your print. So having this knob is really easy to load and unload it, so you don't have to worry about accidentally pushing down when you're squeezing. And we've had, it's kind of a common thing when kids are like squeezing it and pulling it, because, I mean, you know, kids don't always know their own strength. So they're like, I got it. Like,
yeah, and I just did that too when I was earlier.
So it helps having that little knob. That'll help a bunch. So yeah. I'll send you this video recording and all those links and stuff that I talked about. And if you have any questions or anything, just get a hold of us and we're here to help.
All right, sounds good.
All right. Well, y'all have a good one.
You too. Thanks, Drew.
You bet. See y'all.
You too.